Hello everyone. Today we are going to explore an exciting topic, the history and evolution of machine learning. By end of this session, you will understand what machine learning is, why it's important, how it works, and also its challenges. So let's get started. Now let's start with the topic with a simple question, why machine learning? So machines were developed to process large volume of data beyond human capacity, but traditional programming struggled with complexity, uncertainty, and real-time decisions. Machine learning emerged as a solution enabling computers to learn patterns from data, adapt to changes, and improve performance without explicit programming. So how machine learning evolved from early era. Let's look up to it. So in early era, the concept of AI and ML was introduced, where perceptrons, neural networks were introduced to the people, but they were limited to low computing power. In the middle era, it gave rise to some practical algorithms like decision making, decision tree, SVMs, and clustering, which were widely used for pattern recognition and data mining. In the modern era, the machine learning evolved in such a way that it can be used for big data and GPUs, which enabled deep learning, natural language processing, and real-time AI applications like healthcare, robotics, and self-driving cars. Let's look up for an example like self-driving cars. They use continuous learning from millions of driving data to make safer decisions. Moving ahead, let's understand what is machine learning. What's the core concept behind machine learning? So machine learning is a branch of artificial intelligence that enables system to learn from data, recognize patterns, and make predictions without explicit programming. So the core idea behind machine learning is it instead of using fixed rules, it machine learning algorithm analyzes the data and improves automatically with experience. So the key features behind machine learning are it is a data-driven, adaptive and predictive model which works on refining performance and forecasting outcomes in dynamic environment. There are three basic types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So supervised learning works on labeled data. Unsupervised learning works by finding hidden patterns in unlabeled data. And reinforcement learning works through feedbacks and rewards given through the data. So let's understand the concept of machine learning by an example. So for example, detecting fraudulent credit card transaction in real time is difficult for the banks as a traditional rule-based system cannot be keep up with evolving fraud patterns. For this, machine learning provides a solution where the models are trained on past transaction data to recognize unusual transaction in the account so that they can identify unusual patterns that may indicate fraud. This allows bank to flag suspicious transactions instantly and protect the customers. Now let's understand the working mechanism of machine learning. So the working mechanism is divided into five steps. The steps are data collection, data pre-processing, model training, evaluation, prediction, and improvement. So in data collection, we gather raw data from different sources such as images, text, numbers, or sensors. And the quality and quantity of the data is very important as it directly affects our model's performance. Then comes the next step, which is data pre-processing. In this step, we use the raw data and we clean the data, we organize the data and transform the data in a format that is suitable for processing it. Then in this stage, we also handle the data missing values, normalize the data and create features for learning. Then the basis of the data that we have converted into a suitable format, we train the model by using perfect algorithm that is required for the model, such as decision tree and neural networks. Then after that, we feed the data as feed training data so that the model learns patterns and relationships from the data. Then for evaluation, we test the model on unseen data, which is also called as testing data or the validation data, where we understand that the model can predict other than the data that we haven't provided to it. On the basis of it, we understand the major performance using accuracy, precision, and recall. After evaluation of the model, we predict and see the improvements that are required in the model. So for that, we use trained model to make predictions on new data set, and we understand how well the model is predicting the output. And after predictions, we understand the accuracy of it, and to make the model more efficient, we make continuous changes into it to make the model work perfectly. Now, moving ahead, let's see what are the limitations and challenges that we face in machine learning. Data dependency is one of the major limitation in machine learning, where the machine learning models require large amount of quality data to perform well. If the data is poor, biased, or insufficient, data leads to inaccurate predictions. This also causes lack of transparency, which limits trust in sensitive fields like healthcare or law, where accuracy is important. Models trained on specific datasets may fail to adapt new unseen scenarios. Training complex models requires high computing power, memory, and energy, which leads us to financial limitations. For example, facial recognition. Problem caused in facial recognition is where it works well on some demographic but shows a high errors on other due to biased training data. Limitations raises fairness, privacy, and ethical concerns. Summarizing the whole today's machine learning concept, machine learning emerged to overcome the limitations of traditional programming by enabling system to learn from data, adapt, and improve automatically. Over time, it has evolved from some simple perceptrons in the early era to particle algorithm in the mid era and to the advanced deep learning models in the modern era. It works mechanism involves data collection, pre-processing, model training, evaluation, and continuous improvement. While ML offers powerful solutions like fraud detection, spam filtering, it also faces challenges such as data dependency, bias, and high computational demands. Overall, machine learning stands as a dynamic field driving innovation in real world applications like healthcare, finance, and self driving cars. Thanks for watching the session.